Hello, welcome to factoring and solving higher degree polynomials. And what we mean by higher degree polynomials is they aren't going to be just x squared. So let's look at our first example, x squared plus 3x plus 2. We know that that's going to factor into x plus 1 times x plus 2. But we can apply this same knowledge to the problem if it were y to the fourth plus 3y squared plus 2. You will notice that we have y to the fourth and y squared. This will factor into y squared plus 1 and y squared plus 2. The same pattern for our x squared plus 3x plus 2 can be applied to when we have y to the fourth. My advice to you is to always just multiply it back together to make you sure you get the original. Another way to think of this is y to the fourth is really y squared plus 3y squared plus 2. And you can factor it from that pattern as well. So let's look at number 1. We want to factor x to the fourth minus 1. This is really x squared minus 1. So it's following the pattern of difference of perfect squares. So it's going to be x squared minus 1, x squared plus 1. And you can see that if you multiply x squared times x squared, you get x to the fourth. The middle term will be 0, and negative 1 times 1 is negative 1. But you're not finished, because x squared minus 1 is a difference of perfect squares, and it will factor into x minus 1, x plus 1, but x squared plus 1 is a sum of perfect squares, and it will not factor. Number 2, it's an x cubed, and we have 4 terms, so we will factor by grouping. Take out the greatest common factor. Personal preference, I just like to put a 1 there as my greatest common factor. So our factors are x minus 1 and x squared plus 1. Number 3, the leading coefficient is negative and it has a greatest common factor. So it has a greatest common factor of negative 3. And now I'm going to factor, I need the factors of 24 that add to 10. This one is kind of just a review problem because it's not a higher degree, it's x squared. So our factors are negative 3, x plus 6, and x plus 4. Number 4, I'm going to rewrite it. There's a greatest common factor of negative 4. Going to have to use the AC method. 8 times negative 9 is negative 72. The factors of negative 72 that add to 21. From here, you can use factor by grouping. you can use slide and divide. Of course, my method is slide and divide. So I'm going to go x minus 3, x plus 24, and then a is 8. So I'm going to divide by 8. So my final factors are -4, 8x minus 3, and x plus 3. Number 5, greatest common factor, x squared. X squared minus 4 is a difference of perfect squares and factors more. And so there's our final answer. Number 6, I suggest you factor it as if it were 2x squared plus 7x plus 3. And when you factor this, we have 2x squared plus, we have 2x plus 1. And x plus 3. So that if we were going to now factor, do you hear my dog barking in the background? Just ignoring. If we want to factor 2x to the 4th, it's just going to be 2x squared plus 1. Oh, and x squared plus 3. So now we have 2x squared plus 1 and x squared plus 3. So as I was saying, you can take the factors, if it were just 2x squared plus 7x plus 3, and apply that to 2x to the 4th plus 7x squared. Okay, so let's look at number 7. Again, we can factor this as if it were c squared plus 6c plus 9. So we need the factors of 9 that add to 6. So 3 and 3. So if we were to factor as if it were c squared, we would have c plus 3 and c plus 3. But what we really have is c to the 4th as our first term and c squared as our second term. So our factors are c squared plus 3 and c squared plus 3, or c squared plus 3, all of that squared. Again, I can't stress enough how important it is just to multiply your factors back together to make sure you get the original. Number 8, it looks like a difference of perfect squares. It would be if it were b squared minus 9, but instead it's b to the 4th. So we're going to have b squared minus 3 and b squared plus 3. Number 9. Again, it's if it were a squared minus 81, it's going to factor into a plus 9, a minus 9. But it's a to the 4th, so we need a squared times a squared. Maybe that helps a little bit. And then minus 9 plus 9. Multiply that back together, you're going to get a to the 4th minus 81. But you'll notice a squared minus 9 is a difference of perfect squares. It will factor into a minus 3, a plus 3, another way you can look at number 9 is we could have started off as a squared minus 9 squared, if that helps you see the pattern. There are several techniques for factoring problems like number 9. Number 10, they have a common factor, x cubed. And then we need the factors of 1 that add to 2. So you can write your answer either of the last 2 lines. Okay, number 11 and 12. You'll notice that the third term is now a squared, a variable squared, different than what we've seen before. But if we approach factoring to number 11 as if it were 2x squared plus x minus 1, and we need the factors of -2 that add to 1, and we factor this, I'm going to use factor by grouping so I can kind of have a little variety. Then we have x plus 1 and 2x minus 1. Well, that's not the original problem because we need a y squared. So when you multiply the last, we get -1, but we need a negative y squared, and in the middle term, we need a positive xy. So we can apply this same pattern, and we would have x plus 1y times 2x minus y. And that's the answer. And your teacher might have another way of explaining this, so be sure to ask. Number 12. We can always factor a simpler problem. But if we approach this one as a squared squared minus 2a squared b squared plus b squared squared, that is the same problem. So we need the factors of 1 that add to -2, which is -1 and -1. So we need a squared in our parenthesis, and we need to get a b squared. So we're going to have a squared times b squared. I stand corrected, we need a b to the 4th. And then we need a squared minus b squared. So if we multiply this back together, a squared times a is a to the 4th. The middle term, negative a squared b squared plus negative a squared b squared is -2a squared b squared. And negative b times negative b squared times negative b squared is positive b to the 4th. But you might notice that both of these are difference of perfect squares. So we have a minus b, a plus b for the first parenthesis, and a minus b, a plus b for the second parenthesis. We can put all this together and write it as a minus b squared, a plus b squared. This was a good challenge problem. I'll give you a hint, it's not on your test, but you definitely need to know it for your next class. So the next set of practice problems, we're just going to solve them. So we know that to solve a quadratic or a higher degree polynomial, we need to factor it and then set all the factors equal to 0. So that's all we need to do. We're going to practice a little more factoring. So number 1, the greatest common factor is 2y. And we need to factor the factors of negative 18 that add to negative 3. Let's go negative 6 and 3. And set all the factors equal to 0. So our answers are y equals 0, 6, and negative 3. Number 2, this must be equal to 0. So I need to subtract 50x from both sides, subtract 75 from both sides. I can see that there's a greatest common factor of 25. Now we just need the factors of negative 3 that add to negative 2. And we can divide both sides by 25. Not going to change our equation. It's still going to be equal to 0. Add 3 to both sides and subtract 1 from both sides. Again, you can take your answers, take 3, substitute in the original equation for x, and both sides should be equal. And the same with negative 1. All right, number 3. There's a greatest common factor. We need the factors of negative 4 that add to negative 3. Negative 4 and 1 multiply to give you negative 4. Negative 4 plus 1 is negative 3. And this time we have to set y equal to 0, as well as y minus 4 equals 0, and y plus 1 equals 0. So our 3 answers will be 0, 4, and negative 1. Number 4, greatest common factor is x squared. X squared minus 36 is a difference of perfect squares. So we have x minus 6, x plus 6, and set all your factors equal to 0. And there you have it. You can write your answers as 0 and plus or minus 6 if you'd like, or you can leave them the way they were. And finally, our last two. Need to add 36 to both sides. We need the polynomial equal to 0 before we factor. We need the factors of 36 that add to negative 13. because it's an x to the fourth minus 13x squared. Our parentheses are going to be x squared. So x squared times x squared is x to the fourth. You will notice that both of these are a difference of perfect squares. Now we have 4 factors to set equal to 0. And there you have it. And number 6, our last one, we have 4 terms. We need to factor by grouping. Take out the greatest common factor. N squared minus 1 is a difference of perfect squares. And set all the factors equal to 0. So we have n is equal to 2, n is equal to 1, and n is equal to -1. And there you have it. This concludes the most exciting video on factoring higher degree polynomials and solving them. Till next time, goodbye.